we have my first cal driver.c, which is registered for 247 comma 0, and we have the my first dot ko, which is registered for 246 comma 0. And when you will look into the device file, when you will look into the device, there is no device file with these numbers. Okay, there is no device file with these numbers. Okay, it doesn't exist. So the point which I was trying to make, as I told you, creating a driver doesn't necessarily means that the device file will be created, because device file is in the user space. So what you need to do, you need to manually create the device file. For example, when we loaded it, this guy, or from the cat slash proc devices, cat slash proc, I have got, like, if I want to interact with this driver, 247 is basically the number. So what I will be doing, there is a command by name mknode slash dev. I can give any name over here. Let's say I'm giving a name over here. It's a file name, right? My device, my device. C 247 0. Okay. When I do slash div, my device, what I've got, character special file bearing the name my device, bearing the major minor number 247 comma 0. And we know that it's our driver, which is supposed to serve that. So that means link with a VFS. That means when you register your driver with a VFS, you told I'm responsible for 247 comma 0. Now in the user space, you need to create the device file with that major minor number. Okay, so that means VFS has no role to play. VFS has, like, someone is, if he's operating on that device file, VFS will say, okay, fine, I have the driver. So I can say basically, yes, I basically have this particular device. I have this particular device file. Now I'm operating on this. I already have the driver. So the role of VFS is just to redirect. When you operate on this, this my device, it has 247 comma 0, and the driver for this is what we have registered, my cat. So VFS will connect us to that. Making sense? Okay, so now let us bring in the application. Let us bring in the application here. And the application which I have already provided you is file ops. What I'm going to do, I'm going to cross compile this, because it is for you'll be trying on the system, so you just need to do gcc file ops. Okay, but here I will be using arm none. It's a cross compile, it's on the beagle bone black, that's why arm none. Okay. uh, Linux GNU GCC. I'll give some name file ops to this guy. I'll do the SCP of the application. Okay, over here. Let me just show you how does the application looks like. It's a very simple application. What it does is it takes the file name as an argument and invokes open on that. And further, if you select that choice, it will invoke read. It will invoke write. You can say as if you are operating on the regular file. You opened it, you write into this file, you read into file. So that is how the application looks like. So what I will be doing, file ops, I will be transferring it to the board. Here, what I will be doing, slash dev, I created one file by name my device, right? 247 comma 0. My driver, my driver is also registered for this major minor number. So I am basically satisfying the link that driver is registered for this number. My device file is also bearing the same number. That means VFS should be able to connect me to my driver. Let's see. So I will run file ops slash dev and my device. So I get the options open, read, write. I try to open, but it is failing. Okay, it is failing. So what is the reason for this failure? Anyone having any idea? Whoever might have worked with a driver, you might have some idea about why is this failure. Yes,
We don't define an open operation inside the driver.
exactly. Right, right, right. Okay, so the thing is, when you come to this particular stuff, you have the application, you have the open, you invoke the open over here, and here I'm saying like VFS will invoke your open. But if you look into your driver, if you look into your driver over here, first char driver.c, we don't have that callback handler. We have just told that I will be serving this device file. But what services are you providing? See, let's say if I open a shop and I say, like, okay, I will be serving my customers. But what services are you providing? That you need to tell it to the VFS, that will you allow write into the device? Will you allow read from the device? Will you allow opening the file? Right now, we have not provided any of these services. That means VFS knows that on this device file, whenever any request come, I am supposed to basically invoke a callback handler for you, but you have not provided like what services you are providing. So that is where we come to the next stage, where only registering or deregistering your driver for the major minor number is not enough. You also need to provide the file operations, which are like open, read, write. You have to tell what services do I provide. Okay, like you see file operations, there might be some 20, 30 operations available: open, read, write, seek. Depending on the type of your device, you will provide that service. Okay, so typically what you provide open, read, write, close. Those are the most common thing, and then there is IUCTL, which we'll discuss in the next session. So now the question comes is, how do we register for the file operations? So I'll take you to the another file, another driver by name null.c, in which I have already predefined those operations, and I'm going to show you the process of how do we register with that. So what I need to do is I will have one structure by name cdev. Okay, and this is what this is, it stands for character device. Okay, character device. This is where you will have to provide your operations. How? We are going to see now. So the very first thing is you populate your callback handlers. Open is equal to my open. Read is equal to my read. Write is equal to my write. So you are basically saying that whenever application invokes open, This is my callback handler. Whenever application invokes read, this is my callback handler. Whenever application invokes write, this is my callback handler. So you are registering your services with a VFS. First, you registered your device with a VFS, or you registered yourself with a VFS that I'm a service provider. Now you are saying, as a service provider, what services do I provide? Okay, so that's how the things are. Now, this is just populating one structure variable of this type. But what we need to do next is we need to register. For registering, there's a two-step process. What you do is you call something called cdave init. And what do you do in a cdave init? Again, don't need to remember the APIs. There is something called apis.txt which I have provided you. So we'll just copy paste this stuff and I'll copy paste this stuff, and now I will explain you what does it means. So okay, so let's see what we are doing here. So cdave init, we have the structure of type cdave pointer to that. File operations, we registered, we basically declared one structure of type file operations. Driver fops, let's take this and what we will do is register over here. So sorry, not register. What we are doing is initializing the structure. Initializing, there is one field called fops in the cdave. Initializing the field fops of cdave with our fops. That's what we are doing here. Okay, this is what it is doing. Initialize cdave with our fops and remove this. And now comes the important step where you are registering your services with a VFS, and that's where you will have cdave add. So again, what you will do, and here you need to provide the major number or minor number to which you are going to provide these services. Okay, so that is very important step, because when you operate on 250 comma 0, you are saying that I'm supposed to provide these services to this major minor number. So what I can do over here, let's say I have got the major number over here 247. Okay, so let me otherwise do it something like this. Here I got 240 comma 0 or whatever. I don't care. Actually speaking, this, see, this is populated by the kernel, right? So I just provide this, and in this there will be 247 comma 0, 246 comma 0 or whatever. I just directly pass it over here. And here what I'm saying is I'm just supposed to serve one minor number. That means here I'm specifying whatever major number I get, I don't care, comma 0. This major number can be 250, 247, 246, whatever, maybe this major number. The zeroth index, the zeroth minor number of this is what I'm supposed to serve by doing this. Hope it is making sense. Okay, clear to everyone? So you have registered your services. And counterpart of this, it's already done. You don't have to do. So this assignment has three to dos which we need to complete. And now let's see what happens. I'll just, and then I will put null.ko. I have transferred this file its mode null.ko. Now the device file name is separate, registration is separate, so it should not matter, right? So I'll just do ins mode. Now you see I have got 245. I have got the major minor. Now there will won't be any file with this major number minor number. I have the file we created. Sorry, my bad. We have the one with 247, but we don't have any with 245. So what I need to do, I need to create it. I'll do mk node slash div. I give the name xyz 245 0. Okay, I created it. Now let's do file ops slash div xyz. Let me perform the open. Side by side, I will open my driver as well. Let me run it. And I'm opening my driver as well so that we can see that in parallel. Vi null.c. Let me open this stuff. So we have this stuff. What I'll be doing when I call open, you see what we are getting? Driver in open. That means my open is getting invoked. Okay. Now let me do a read of this. Okay. Let's say I'm doing a write. So I'm invoking a write operation which will invoke the write system call. As I'm putting this driver in write here, driver in write gets invoked, and what this guy is doing, it is printing the ASCII value of what you have sent. That means when I send Pradeep over here, the ASCII values of those are coming from here. Now, if I say read, let's say I want to read 5 bytes, it says driver in read. That means my callback handler got invoked, but I got a 0 bytes over here. Okay, I got a 0 byte over here. Why? Because I'm not returning anything from the driver. That's why. This is how the null driver behaves, right? Null driver is something like when you say write something, it will say, okay, return. When you say read something, it will say, I don't have anything. That's how we use in the scripting and all the time. Whenever we want to redirect something to the null, we basically use this stuff. See, what we do is I type some command ls minus l and I want to redirect the output to slash dev null. Now when I do cat slash dev null, will I get anything? Nothing. So it's a null driver.